Hello, everyone. Oh, that was loud. So, welcome. Thank you for coming to our session. How many of you out there have customers with .NET web applications that are in need of an availability or performance monitoring solution? Great. How many are using third-party right now and you'd like to move them? A smaller number. Interesting. Okay. Well, today I'm Charlie Satterfield, and I'm here with Jim Dobbin, and we're going to talk to you a little bit about web availability monitoring using Global Service Monitor. We're also going to talk about Visual Studio web testing, and then also about application performance monitoring. By now you've seen this slide at least several times. Not everything in here is confidential, but enough is that this slide exists. Please, no screenshots, no cameras, no recording devices. It will be posted on TechReady TV for later consumption. Today, we hope to review the capabilities in our use of web availability monitoring using Global Service Monitor, as well as Visual Studio and the application performance monitoring. We hope that you understand some of the benefits that we see in these features that you can then take and relay to your customers and hopefully get better adoption. A little bit about what we're talking about today. We'll talk a little bit about monitoring management, which is the team that I'm from, how we think about monitoring. We'll talk some about what is in the box with System Center Operations Manager 2012 SP1 as far as app monitoring. We'll review a little bit of app monitoring in action, and then we'll talk about some of the challenges that we've had in our existing implementation and what we've had to do to try and change so that we can better use some of these features. Before I get to this slide, I do want to emphasize, if you have a question, please raise your hand. We'd like this session to be as interactive as possible and make sure you get as much information out of us as possible so you can better relay that to your customers. So about monitoring management, we're a team within the product group. We exist within Cloud and Data Center Management, which is part of the System Center product group. And we are actually an operations team that exists within the product group. That's very important because we actually are the first ones to cut their teeth on the latest features and give them feedback that they in turn roll back into the product as far as bugs or feature sets. And as you can see, some of our customers are the largest properties at Microsoft externally facing, like Microsoft.com, Windows Update, the Windows Store, MSDN TechNet, among others. Our Operations Manager presence spans 10 data centers around the world. It's effectively around 9,000 servers that we're monitoring and managing across those data centers. And all up, we generate about 3,000 alerts and incidents daily. A little bit about our team. Part of our service offering, we have a Tier 1 team, which is 24/7. It consists of mainly vendors, about 40 of them, that are split between Redmond and India. So we maintain that 24/7 presence. They have a 15-minute SLA on any incident that gets created in Service Manager. They have 15 minutes to either resolve that incident or escalate it to the appropriate engineering team for resolution. We have a Tier 2 team. These are the folks that generally keep the lights running on our Operations Manager and Service Manager instances. This consists of about 4 vendors with a full-time manager. And then we've got Tier 3, 4 full-time service engineers. These folks are doing most of our technical planning and experimentation as we move into new technologies. And then I'm a full-time PM architect on the team. We also have another service manager that maintains some of the relationships with all our customers. How we think about monitoring. We think about monitoring from an inside-out perspective, which is sort of the traditional operations manager model, which is event and counter-based monitoring. It requires that an application developer has put in sufficient eventing in their app so that we can actually monitor for those events, fire off alerts when those occur. It also covers most of the operations manager retail MPs, which is the OS, hardware, IS, SQL, those sorts of things. So that's all agent-based, a little bit of agent list, but mainly just gathering events and counters via the agent. As we think about outside in is really looking at some of the experience you'd see from an end user. Is the web application available? Is the web service functioning as it should? And these are mainly looking at HTTP probes, using either third-party URL monitoring, or we actually developed our own in-house outside-in monitoring solution, and then also using some of the built-in functionality with Operations Manager. Also, from an outside-in perspective, that's when you want to understand your global perspective. If you have an application that is available and serves a customer base that is around the world, you want to understand what the experience is from Tokyo. You want to understand what the experience is from Paris. You don't just rely on local HTTP probes to give you that information. I need to stop with the tongue twisters. With System Center 2012 SP1, we have a variety of options as far as our application monitoring. You have some of the traditional templates that existed all the way back into 2007, which included the web app transaction monitoring tests. If you are familiar with Operations Manager, you've seen this. It's been around for a while. What was new with 2012 and enhanced with SP1 was the web availability monitors. This is the ability to actually it's more of a ping test on a URL and understanding whether the application is available, gathering some basic performance counters. New with SP1 is the Visual Studio web test. This is the ability to actually open up Visual Studio, record a web load and performance test, upload that into Operations Manager, and be able to gather pass-fail on that test. And then last, we have the application performance monitoring, which was formerly known as Avicode. This was enhanced with SP1, and now it can actually monitor some .NET services outside of IIS. As far as web availability monitoring in GSM, our customers, Microsoft.com, Windows Update, MSDN, TechNet, are heavily utilizing right now our custom solution as well as third-party solutions that we've implemented. As we look to implement web availability monitoring with GSM, we look at several different types of tests that they run. They run some base URL tests. These are typically executed by an external source, and so we'd look to replicate these with GSM. They run a virtual IP test, and this we'd also look to replicate with GSM. Then they also run something internal, which is a dedicated IP test, which allows them to pinpoint failures to specific web servers. And these aren't accessible from external to the network, so these are things that we would run using Operations Manager from inside the network, from inside Watcher nodes, either a management server or an agent. How many of you are familiar with the web availability tests? Have you run them? A couple? How many were in Daniel Savage's Chalk Talk just a few minutes ago? All right, so you've been through a little bit of this, but I'm going to go through a little bit of a demo as far as how you set up a web monitor test, some of the configuration options, and then what some of the dashboards and reports are that you'd be able to leverage. All right, you can see that. All right, so from within the Operations Manager console, if I click on the authoring workspace, you'll notice we've got the web application availability monitoring listed as an MP template. So if I click Add Monitoring Wizard, from here it's already pre-selected because I was already looking at the test that I had previously created. I'll click Next, and here I'll just type in a demo name. And I select a management pack. for what our customers are going to be implementing, we're recommending that they use management pack names that are clearly understood and limit their tests to just the applications they're going after, not group tests in a single MP, because then it just creates problems if you're moving between operations manager instances or splitting up engineering groups. For the purposes of the demo, I'll use just a test GSM. So at this screen, I can enter in a list of URLs. If I had a spreadsheet open, I can copy and paste a list of URLs in here. It's important to note that in this feature, you're able to add the multiple URLs. In the web app transaction monitoring, you did not have that ability. It was a single URL test that you were enabling. So for this, I will enter in Microsoft.com. All right, so I've added my 2 URLs. I'll click Next. At this point, you get to choose where you want your test to be run from. You can choose from the same screen here, either external locations or internal locations. I'll go ahead and right now click External Locations. Go ahead and search, and you can see there's about 18 different watcher nodes around the world. And for this demo, I'll just go ahead and select all of them. I'll click Add. So I've now added these external locations. I can, in the same process, go ahead and run this test from an internal watcher node if I wanted to understand the availability and performance of that same app from inside my network. So I'll go ahead and click Search. And you can see I've actually added location to some of these management servers and gateways. I'm going to select this gateway, and I'll add it. You can add those locations. You can't do it through the Operations Manager console. However, you can do it through PowerShell. I'll reference a blog at the end in which you can go get the details on how to associate locations to either agents or management servers. So I'll go ahead and click Next. On this screen, it's listing out all the tests and locations that they will be running from. And you can see here my test frequency is by default set up to be run this test every 10 minutes. And it gives me a breakdown of the number of internal tests I've configured and the number of external tests I've configured. It's important to note that a test is seen as just a URL and location. So that's why it's saying that I've got 2 URLs tested on 1 location internally and then likewise on the external. If I go ahead and click Change Configuration, I can actually increase the test frequency and change it to be 5 minutes. I can also change my test timeout. I can change the performance data collection interval so that it's not checking the performance data every time, but rather every other time or every third time. And then there's the ability to actually customize the alerting criteria or the warning criteria that you desire for the test. So I'll go ahead and click OK for now, and then click Next. And here's my summary. I'll go ahead and click Create, and it's going to go off and actually create this in the MP that I designated, and then it'll start to upload that data to GSM. It may take about 15 minutes before you start to see data flowing back from GSM. That's just what we've seen. Sometimes it's a little faster, sometimes it's a little bit slower. So now that you've created your test, what do you get? With Operations Manager, you do get the health of an application. So in this view, I'm viewing web application status. And you can see I've got 2 previously created. It's not showing the third one that I just created because no data has come back yet from GSM. But I can tell from this that my test Microsoft.com application is failing, but test MSDN is succeeding right now. Now, if I wanted to dive in further and understand, well, where is that failing from, I can go ahead and open up what is called the summary dashboard map, which I already have open. And this gives you a view of all the agents that you're running tests from, both internal and external. And you can see I've got one that is showing up in red, and that's my Bay data center down in California. And that's the internal location that I've configured and associated that location to. And the failure actually is occurring, all right, because the response time is exceeding 4 seconds. So in my test that I had configured, I wanted a maximum transaction response time of 4 seconds. So this one's failing it. I need to go off and figure out why I'm getting such poor network performance out of that data center. Now, another view is the detailed dashboard list. I'll open that up. In the detailed dashboard list, I get the list of all the locations I'm running the test from in this left pane. I get to select, if I've selected all of them, I can then select the test status that I wish to look at. And then I get to narrow in on the different performance counters that have come back and have been collected by each of these tests. And you notice you can see fairly easily some of the outliers. You've got my internal test with a very high total transaction time. And then you've also got a content time down here, and it's stale data, it's still refreshing, from a Zurich watcher node. So that's another area where I'd go and assign an engineer to go figure out why am I getting such bad content time as compared to everything else. Now, this gives you sort of a snapshot view of what's happening right now, what's my performance over the last hour. If you wanted to actually look at this over a longer period of time, you need to leverage some of the availability reports that are built into Operations Manager. So you can access that from, the Web Application Status View. So if I click on one of these, you'll notice in the Report tasks, a Web Application Availability Report. If I click on that, that'll launch that availability report for the objects I've selected. If I've selected more than one object, it'll include each of those objects in the report. I already have one open, so I'll show you what that looks like. So for this, I'm actually looking at the MSDN web application that I've set up. And I've already drilled in once so that I get actually a view of the availability from each of those watcher nodes. And I can dive in even further if I wanted. So you can see here, I've got a very small sliver of downtime. And I could dive into each one of these watcher nodes and zoom in on exactly the period of downtime so I can understand where my downtime occurred. So let me zoom in on this guy here. And you can see it's very small, but I've got a window of downtime that occurred over the past couple of days. And I can zoom in even further to look at just a single day view. And that should show me the exact period of time that I experienced my downtime. So you can see between 4 and 5, I experienced a bit of downtime, and that was on December 3rd, or February 3rd. So from there, how do I go and get the alert information? Well, I'm not able to, unfortunately, click right on this downtime and bring up the list of alerts that occurred. I actually have to go into the Health Explorer to this particular node for this object, and then go look at the state changes. And that's how I can get to the information about what occurred around this event. As soon as the test goes from a failure state to a successful state, it flips that back to a healthy state, and so the alert is auto-closed. So to get that information, I actually have to dig back into Health Explorer. All right. So with that, let me switch back to our presentation here. So some of the things we like about web availability monitoring and what it's bringing to our customers, the ability to provision multiple URLs within the single workflow. This is important. In previous feature sets, it was just one URL at a time. It was really time-consuming to set up these tests. Easy to provision those tests to both a GSM watcher node as well as an internal watcher node. We have multiple requirements as far as being able to watch watch a URL availability from multiple data centers internal to our network, as well as seeing that outside customer view. So this is important to us. Automatic health rollups. This is a no-brainer. It's because it's an out-of-box operations manager feature, you get the health rollups and the ability to add these to distributed app models like you do any other object. The availability and performance dashboards are very useful to us and our customers. They give you that nice view of what's going on at that point in time or over that past hour in the performance dashboard view. And then lastly, the availability reporting. The ability to drill in and see the exact downtime periods is very beneficial to us, but it's a feature set that is sort of on par with what we have been providing with a custom solution, but it's a very nice feature for our customers. Lastly, it's free. If you were in Daniel Savage's presentation, he mentioned this already. If your customers have an existing SA, they get this for free with their operations manager licenses. Out of the box, you only get 25 tests. But as he mentioned during his session, if they have a lot of operations manager licenses, they are willing to increase that amount. Challenges as far as how we're using web availability monitoring. Some of our customers, Microsoft.com being one of them, have thousands of web monitors that need to be configured and modified and updated. This is challenging in the current UI flow. While you can add multiple web URLs to a single monitor, you can't modify the settings of multiple monitors at once. There's no ability to do so currently with their PowerShell capabilities. Next, no way to view those alerts that corresponded to the downtime in the availability reports. This is something we're communicating feedback back to the product group and trying to get some better functionality there. Next, there's no breakdown of performance data for the components on the page. If you're familiar with Internet Explorer's developer tools, the moment you load up a URL, you get a performance breakdown of how fast each of the particular components loaded on the page, and you can see some of the offending components that took the longest to load. This is something that is available with some third-party solutions, and so it's something that we're still looking for from the GSM service. And then lastly, it's that GSM test limits for customers. As Daniel had mentioned, 25 tests is the current limit when you signed up for GSM. However, if they are a large operations manager install base, they will look to increase that. Next, Visual Studio Web Tests in GSM. While the web application monitors give us the ping test and give us the performance of that base page, they don't give us a lot of granularity in the ability to test, did a specific page load, and are these attributes on the page? Can I search? Can it return the results? Can I log in? These are all things that we're able to do now with the Visual Studio Web Test add-in. Let me switch over and demo that. So I'm going to open up Visual Studio first, and then I'll show you how it gets imported into Operations Manager. From Visual Studio, I've already created a project. You need to go in and create a web and load test project. From within here, if I right-click on the project, click Add, there's the Web Performance Test option. The moment I select that, it opens up the web test, and then it opens up Internet Explorer with the web test recorder active. So as soon as I start typing in here and performing actions, it's going to record what I'm doing. So I've just gone to Microsoft.com, and if I search for Windows 8, you can see it's recording each of these steps as well as my actions. So if I wanted to, I could go to a site that had Live ID integration, and I could go and log in with a Live ID username and password, and then navigate through that site just like I would as a normal user. At the end of it, I can click Stop, and it brings all that information back into Visual Studio, every one of those steps. Now, it's detecting if there were any dynamic parameters that existed within each of the steps. And I will tell you, there are dynamic parameters whenever you go to a live ID site. You do want to accept those dynamic parameters, as it will not function unless you do so. All right, so it did not detect any dynamic parameters. So one of the cool things that you can do within Visual Studio is I can add additional validation rules. The built-in rules check to see that the response URL is what it expects the response URL to be, and that the response time goal for each step meets a certain criteria. I can add additional validation results by right-clicking on a step, selecting Add Validation Rule. In this case, I'm going to select Find Text, and I'm just going to look for Windows. Click OK. You can see it's added this validation rule just to this step. So now, as the test runs, it's going to perform that search, it's going to return the results, and it's going to look for Windows in the results. So I can go ahead and test my test by clicking the Run button, and it will run through all those steps, and I will understand whether or not what I've just created will function well enough for me to go ahead and bother uploading this to Global Service Monitor. And you can see the test run completed, and it's passed. So now, let me go back to my web test. I'm going to save this. One important note is you need to set the request details to ensure that you don't have any think time recorded in your web test. GSM doesn't accept anything beyond 0 for think time, and that's some of the requirements. I listed other requirements on the previous slide, and I also list those requirements out on the offline. The question, just so it's in the recording here, is what happens when you have to record a session against something that requires think time in the load of the page. I haven't tested it on pages that require some think time. So far on the scenarios we've recorded, we haven't had an issue with that, but that's certainly something that we can take. Okay, so I'll click OK here. I'll go and save this, and then I'll close it. Let's go back to Operations Manager. And again, from the authoring workspace, I'll select Add Monitoring Wizard. And then I'll select Visual Studio Web Test Monitoring. I'll give this a Test Visual Studio. I'll select a management pack. Again, I encourage you to use proper naming conventions. I'll click Add, and then these are the list of the web tests that I've already created. This is the one that I just most recently created. I'll select that and hit Open. It came through with the name of the file. I can change this, and then I'll hit Next. Now, with Visual Studio Web Test, currently it's only supported running from GSM watcher nodes. You can't push this to both the external watcher nodes and an internal watcher node. It is something that I've asked the product group to try and accommodate, and I'm still looking. So I'll go ahead and click Add. And I will associate this with several external watcher nodes. And I'll click OK. Click Next, and I'm back to my test list and where it's going to run from. Again, my test frequency is 10 minutes, and the number of tests I've configured is 5. If I click Change Configuration here, you'll notice my options are a lot fewer than they were with web availability monitoring. That's mainly because it's going to take the test, it's going to execute the test as you've recorded, check any validation rules within the test, and return a pass or fail. It's not going to record performance results along the way and bring those back for validation once it gets to Operations Manager. So you're left with determining how often this will run as far as test frequency, and then specifying the number of consecutive times a criteria should fail before it throws an alert. In this case, every time it fails, it's going to throw an alert in our operations manager infrastructure.
Yeah.
So the generate alerts from each test, we typically go with that option because it gives you all the information that you need to start actually investigating it without having to open up the operations manager console. So we use operations manager and service managers connected to that. So we work everything through service manager incidents. So all that data flows through and creates an incident in service manager. The generate, I'm sorry, real quick, the generate a single summary alert option throws an alert that something is wrong, but it doesn't provide a lot of specifics. So that's one reason that we aren't using that. And I don't have an answer as to why they've selected one over the other, but in our experience, the single alert is, the alerts from each test is the much more valuable option. All right. So as I go, I've accepted my configuration as is, test frequency of 10 minutes. I'll click Next, and then I'll click Create, and this will go off and create that test within the MP that I've specified. Now, as far as the options on how I view the results, you don't get the detailed dashboard or the summary map. You do get the health and you get the availability monitoring. So if I were to click over to the monitoring tab, you can see here I've got my Visual Studio web test status, and I've got one that I've already created, so it doesn't have the one that I just created. That'll take a good 15 minutes before I start seeing any data. So I do get a summary dashboard map that tells me where my failures occurred. What I don't get is the detailed dashboard, which includes all the performance information that's collected with those web availability tests, not with the Visual Studio web test. You can still run the old web recorder that was part of the web app transaction model, and that's been in existence for several versions now. Go back over to our slides here. Now, with Visual Studio Web Test, we're really excited with the ability to add the transaction recording, the ability to record web actions as the user would input them into the browser. That's something that we haven't been able to offer our customers, and it's something that they've been going to third-party solutions for. So we're very, very excited to be able to add this. Next, the transaction authentication capabilities, the ability to actually log in. Most of the sites that we're monitoring have some sort of login factor. If you can't get past that to monitor the pages behind it, you've lost. So we're very excited about that. Next, the ability to add specific validation to each step along the way is important as we look at a bunch of the pages that require that login. So if we were navigating through some of the portals, we want to make sure that each page has some proper text on it, or we're checking other factors on those pages. And then lastly, again, it's free. The credentials are stored as text in the web test. They don't currently have support in GSM for adding those and binding those to a data source, which is possible running Visual Studio Web Tests natively out of Visual Studio. But currently, those are stored within the actual web test executable. Challenges. So we'd love to be able to record these web user sessions and then play them back on an internal watcher node. The fact that we're limited in the number of tests that we can upload to GSM is a challenge based on the number of pages that we have to monitor. Next, we aren't capturing any performance counter data with the Visual Studio Web Test. So we've got to set up a test in the Web Availability Monitor to capture availability and performance. And we've got to set this up if we want to understand more transactional availability and health. And then lastly, GSM test limits for large customers. I think I already spoke to that. A limit of 25 on the web availability monitors, and the limit, Daniel advertised it as being 25 or less on the web test, or on the Visual Studio Web Test side. So with that, I'd like to ask Jim Dobbin to talk a little bit about his use of APM.
Thanks, Charlie. My name is Jim Dobbin. I've been working with Microsoft.com systems for about 10 years now. One of my primary jobs is to actually debug live site issues on like www. So Charlie asked me to come over and talk about how we think about APM, how we use APM in production, and really how it's kind of changed the way my team works. A little bit about Microsoft.com and what we run. We run www.microsoft.com. We run the Download Center. We run several others, Profile Careers, a bunch more. www is our busiest site, taking about 20,000 to 28,000 requests per second every day throughout the day. That comes out to over 1.6 billion requests served every day from typically 57 million unique IPs. Lots of connections. We're ranked the number 9 corporate website on the web in terms of corporate reach. A little bit about our architecture. We have 24 www front-end application request router servers that kind of acts as reverse proxies back to different content clusters. The main www content servers, though, are 64 of them on the back end, and that contains the majority of the content. We've started kind of a new architecture project, and we're kind of getting away from the old monolithic server style and moving it to smaller clusters of different content. So we're hosting sites like Surface, volume licensing service center, and stuff like that now are back on their own clusters. We try to maintain a global SLA of platform availability of 3 nines, 99.9%, and we're moving to GSM to measure that. That'll be our baseline platform. And our objective of global 99.8% delivery of pages. And we use Keynote to measure that because it gives us a much richer user experience data. It grabs every element of the page, gives you basically perf numbers and availability numbers. So our IIS config is basically, since we're part of MSIT and we participate in the first and best program, we try to get up to the latest version of the OS and IIS by RTM time. So right now we're running on Server 2012, IIS 8 on pretty much the whole platform. www is one of the more challenging sites we run. We host content for a lot of different providers out there, pretty much all Microsoft marketing groups worldwide, a lot of different engineering teams. But basically right now we have over 3,100 applications out there, and those are web applications as defined by IIS. Those are spread out over 26 different application pools on these servers, and we have some of them are kind of isolated for what we call our critical stuff like homepage and stuff like that, but it's a lot of content. We have publishing and authoring systems that are online 24/7, 365, so people can publish content, change code, publish it out there any time of the year, all around the clock. So, like I said, I debug a lot of live site issues, and before APM, this is what debugging in production used to look like. Anybody ever used WinDBG or the Windows native debuggers here? A couple people. So you know the challenges there. Basically, we used to have to pull out a server out of rotation, attach a debugger, load some manage extensions. Hopefully, we had a repro so we could, walk through that repro on that server and hopefully find, some interesting information. Typically, it's going to be some kind of an exception thrown, something like that. Sometimes we'd have to dig a little deeper, but that's basically before APM. That's what we did. Debugging today, now basically with APM out there, APM is now our primary tool for debugging on www. With 3,000 plus applications, we've gone to a model of basically just sampling. We don't push it out to all of our 64 servers. We don't push it out for all of the applications. We just target a few interesting apps and we only sample it on a couple of servers at a time. Since we're a public-facing site, we're very concerned about performance issues, and we don't reference any of the, we don't use any of the client-side performance stuff either, because we just don't want to inject that code out into the, and with our load balancing, I'm not sure that it would work in that scenario. So one of the other things we're pretty excited about is the new TFS integration. So that whole workflow where we can assign an alert right to dev, and it'll be a bug in their TFS. We haven't implemented that yet, but it's something that's definitely on our radar. Yeah, so there's, I mean, some of them are definitely some of them are operational actionable, and some of them are dev actionable. So, my team kind of acts as kind of that initial point of triage. So we look at some of those. Yeah, so it's hard to put numbers to it, but the majority of it is probably something going to be a engineering team involvement. And I'll show you some of the live examples here. One of the real-world examples we had just recently was vNext release of one of the rendering frameworks out on www. They deployed some new features. After deployment, we started seeing intermittent issues on availability as customers started adopting those features. And you can see here from our GSM data that definitely illustrates the problem. Basically, we were down to about 90% availability. So basically, 1 time out of 10, somebody was being redirected to the smart error page. So we basically pushed out an APM config to gather the data. Again, it was an intermittent problem, so old school debugging with the Windows debuggers probably isn't an option just because we couldn't repro it all the time. We started gathering the exception data within an hour. It was very quick, and we started seeing a pattern kind of coming out of that. We forwarded to the engineering team, engaged the engineering team, and with that information, the dev and test teams were able to create a local repro, find the root cause, and basically after that, we pushed out a fix. And you can see the GSM availability is back up to our SLA and our target where we want it to be of around 100%. It took a while. We were able to get, so the engineering side took longer. They are on monthly sprints with their cycles, so we came in at the end of a sprint. We missed one sprint, so it did take us probably a couple of months before we got that fix out there. We were able to do some other operational actions to kind of help minimize the effect, but yeah, definitely. We got various alerts from availability monitoring. Also, the customer was also escalating to us too, saying that because they have their own Keynote feed and they get that data, so they were keenly aware that their site was suffering some issues. But once we pushed out the APM config, like I said, it was literally within a couple of hours we had the data to go back to the engineering team. Well, we target apps that we're specifically interested in based on other KPIs we have. Like this one was one of our critical sites. The availability was dropping, so we just targeted that site immediately. I'll show you some of the live data. We probably only have 20, 30 apps right now that we target. So we basically look at other KPIs, and then that's when we decide to push out a config and gather the data, and then start engaging the different teams from there.
Did you push out a config to just one machine that was running that app, or?
Yeah. Oh, yeah. So we typically only target a couple of the machines out of the cluster. So I think we're 2 to 6 machines, and we tend to use the same machines over and over. And I'll talk a little bit about why we do that a little bit later. So let me just kind of walk you through our typical scenario of what happens. We get a report, or some of our KPIs start showing that there's an application issue out there. So we go through the .NET APM wizard, and I use a little better names than Charlie does. a little more descriptive. And there's my, so choose my management pack. So just walking through this here. So this one would be for, like, say, security portal. So it looks through your IIS application, discovered application inventory. This might take a little bit here. So there I can see www.microsoft.com /security portal is the application I'm interested in. I click on add. I click on OK. I choose my environment of production. And then my targeted group. We have our APM group set up. So on this one, I'll choose my www security APM servers. I believe it's only 2 servers in this group. Go through next here. We typically just go through with the defaults here to initially start with, but I'll show you some of the advanced settings and what I think is interesting. We have the ability to go in and set specific namespaces for .NET namespaces and methods. So there's a couple of cases where that might be a little more interesting for you, but for our initial investigation, we usually just stick with the defaults and go from there. And there's basically that's about it. If I just click on create, it'll create that management pack and push it out. This is our actual production system, though, so I'm not going to do that here. I've already created that one. One of the notes you'll see there, though, is that IIS may need to be restarted. That's kind of one of our pet peeves with it, but we've been able to minimize that quite a bit by reusing the same server groups over and over. The IIS reset's already been done. Typically, the only thing we have to do is maybe just do an app pool recycle, so we don't have to go that full route.
No, it creates a warning in Operations Manager indicating that IIS needs to be reset on that machine. It's up to the engineer to go take care of that.
Yeah, and it goes to our tier 1, and they call us and say, this is our pilot instance. It's fairly small. We just don't think we could consume the data is one thing. Like I said, we have 3,000 applications, 64 servers, and they're all doing 20,000 requests per second. There's going to be a ton of data. So
it's volume. It's not necessarily performance on the agent side. It's more the performance of the management group that is running.
Yeah, and with the way we are load balancing our traffic, every server sees just so much traffic, and that application is going to get hit regardless. So it doesn't take more than 2 of our servers to see some data pretty quickly. So that's the management pack. Now that I've got that pushed out, I can fire up the application diagnostics console, and I can start seeing the data that's being collected. This is the events view. You can see there's just a lot of data, a lot of events coming in. You can filter it based on location or application, different computers if you want. Typically, we just kind of like to zero in on the specific application we're looking for. There's also a computers view that just shows you all the computers out there, what applications they're collecting data for. But my favorite view is the applications view. This is kind of our dashboard. As you can see, it just shows you all of our listed by application, shows you the number of monitored requests, shows you average time, number of exception events for each one, and performance events. So if we look down here at our security portal that we just pushed out, we can see we've collected 10 exception events, no performance events, and we're collecting that on 2 servers and 2 processes right now. The nice thing here is you can just click right on the number of exceptions, and you can start pulling those up. And you can see we've got file doesn't exist. This one's probably not all that interesting for development. It's just a 404. The page doesn't exist here. If we drill in here a little bit, though, we can see the user agent, object URI, that type of thing. This one's probably not all that interesting to a development team, just because it's a 404. A lot of times this could be called, just could be a bad link or something like that. But if you look into this other one here with the .NET exception, if we look at the actual stack here, you can see where the exception was thrown. It was looks like they were making a SOAP call. If I look at the exception code or the exception data itself, we can actually drill into the into some more of the exception data here. Protocols, SOAP exception, invalid command sent to execute XML reader. So something like this might be interesting to development. So I can export this to an MHTML file, send that to them. I can also download the IntelliTrace data. They can use that, pull that right into their Visual Studio, and kind of debug it right there in their Visual Studio, just like they were debugging in production, or very close to it. So that's our exception view there.
I noticed in one of the nodes that you started to open that it was going to show you source code, but you didn't have the
Right. Yeah. So yeah, if you're
symbols.
yeah.
Do you guys typically keep those, or if it's
We don't. That's from the engineering team. We typically don't. With all the content we have, the PDB files would take up a lot of disk space, so we typically disallow PDBs to be published out there. If we old school debugging with the debugger, most of the time we could get what we needed without the symbol files out there. But yeah, we don't allow them in production. We don't even run in debug mode in production. Debug is disabled.
but it's not like a secure, it's just like this space, that type of thing?
Yeah, it's not really a security thing. It's more disk space. The framework, has some different behaviors if you're in debug mode. A lot of different stuff. But yeah, if you look in here, so if a developer, we could actually give them the link to this to our APM console, and they would actually be able to click on these links, click on their stack. They could actually click on this and pull up the source code if they had that enlistment on their machine. And we've done that for a couple of different engineering teams that we work with. Yeah, so we can actually look at I think we already went through this here, but it pulls out the parameters of the SOAP call as well, the request body, so you can see what we were calling there. The 10%,
Yeah,
maybe?
they advertised 5% impact on the agent side.
Yeah, we haven't noticed any performance difference. Like I said, we do a sampling to kind of minimize that, so it's been very minimal. If you get into the set the namespaces and set, if you want to drill into namespaces and methods, that gets to be a lot more expensive. But that also depends on a lot of different factors as well. So we try not to do that unless we have to. And then again, we still are just going to do 2 servers out of the 64 probably. So we'll take a small perf hit for some amount of users, but we'll get the data we want.
Sorry, Jim. And the management group's actually performing fairly well, even though it's the database and data warehouse are stored on the same VM in this instance, and it's a 4-core VM. It's not running Server 2012, so it's actually not doing so bad.
Oh, how do you connect to that? Let me pull that. Yeah, just let me get back to that real quick. You basically just download the IntelliTrace log file. So when you click on download, basically just saves the IntelliTrace log. So typically what we do is we'll download save the IntelliTrace log, save this save the exception data to an MHTML, and send those 2 files off to the appropriate engineering group.
Sorry. Go ahead.
So how does this tie that back into, say, like an application help state? Can do you?
You can.
You can.
In a distributed application, you can use these tests in a distributed app model and include those in your tiered app.
And you can also, with SB1, we can go look at this in a moment. They actually have an application 360 dashboard that they shipped with SB1, so that if you configured a distributed app using their I believe the three-tier template, and add this particular IIS app into that template, it should display that data in that dashboard.
So one other thing I wanted to show you was the difference in the performance test. So this is the go back here. So you have exception events, and then you also have performance events. And that, for what we do, that covers about 90% of all the escalations we get, right? My application is either down or it's performing badly. So if we look in here, this just kind of shows us all the requests that it monitored that didn't meet the SLA of the 15-second default. And you can see there's quite a few of them that are right around 24 seconds. A lot of different URLs, but they seem to all call, either one of the search or get related. So I'm going to drill into one of this get related here, and you can see the stack that you get, the page. You can see basically it was 24 seconds, and it calls out that it's basically waiting 24, almost all of that time is waiting on this WCF call. So you can actually drill into that and see the endpoint address. You can see it's our DLC search service. You can also drill further down into the product ID, see the actual parameters that were passed to that web method. And then the web method name, of course, is get related. So this is the performance kind of view. You don't have, all you can do is export to MHTML. They don't have any IntelliTrace data gathered with this. IntelliTrace is really just for exceptions. So typically in a scenario like this, we'll probably export a few of these to MHTML. But instead of just giving them a few of the events, what we like to use is the reporting for performance. So this is the App Advisor dashboard, and basically lets you run different reports based on this data. It does a great job of doing some statistical analysis of this, of your events, and make counts and what's the number one, SLA issue or different issues basically for you. So I'm going to just go run this really quickly. For source, I'm going to say, let's get Download Center, and let's see what that looks like. So it basically goes through all of your performance data and looks at your top 5 requests. You can see your download details is event count is high, average duration is pretty high. And if we start looking into the resources that are, we can see it's, the number one issue here that it's counted is basically our search service, and it's this get related call. So this might be some interesting data to get over to the dev team or engineering team to work on. So from here we can do an export. Typically we'll export this to a PDF, something like that, or give them access to this console directly. You can export it to several different formats. So we'd probably, typically what we've done in the past is export it to a PDF, include a couple of the MHTMLs for the actual exception or the performance events themselves, and then also give them a report to show them, where they need to really focus their perf work on. And that's about it for my demos today. Go back to machine one. Switch back to the PowerPoint here. So what we like about APM, we like a lot about it, that's for sure. It's really changed the way that we kind of do our work and debug in production. The ability to quickly configure monitors from the already discovered IIS application inventory is great. Profile applications for exceptions or performance events without modifying any code. It's really, near zero touch, non-intrusive, and the integration with IntelliSense just makes it that much easier for the devs to use. The statistical views and analysis of the top failures and performance stuff is great. And the integration with TFS, basically when you have performance events or exception events, now in the Ops Manager console, you can actually do assign to engineering, and that'll automatically create a bug. Does it copy the IntelliSense data?
You can add the IntelliSense data, yes.
Yeah, so it'll actually...
Sorry, question? For the beta of SP1, it was a manual process. I believe with the RTM of SP1, you can set this up to auto-generate.
But like I said, we tend to triage the issues first. And I'll kind of call out, it's kind of one of our challenges too, is that we have a team that it helps to have some operations resource that has some ability to read the code analysis skills and triage the data and say what's going to be interesting for dev, what's going to be interesting, what's really ops actionable, what's engineering actionable, that type of thing. One of the pet peeves I mentioned was the IIS reset required, but like I said, there's ways to kind of minimize that. Some applications still aren't discovered by default. We have certain handlers out there that don't really have any ASPX files out there, so they don't get discovered automatically. You have to go in and take some extra steps to get those to be discovered and show up in your app inventory. And this is more of a wish for me. If it did insight into memory leaks, then I don't think I'd have a job anymore. It would pretty much do everything I want. So turn it back over to Charlie.
Thank you, Jim. So up until recently, we've primarily in the monitoring management space run a very large centralized operations manager management group with 7,000 plus agents, all reporting into that single management group, and then creating incidents in Service Manager 2012. That presented a lot of challenges for us when it came to exposing our customer base to all these great new features, which pretty much required you have console access, and that's not something that we gave out readily across all those divisions. There's quite a few engineers that would want that access, and we really didn't want that many fingers in the console creating issues that could potentially affect other customers. But above that, we did have some product constraints that we were bumping up against. You can only have 400 APM agents reporting back to, or APM agents enabled for APM reporting back to a management group, and then a total of 700 applications being monitored by those agents. With Microsoft.com, we kind of blow that last number away immediately, so it didn't really make sense to stay in just one large group anymore. Additionally, you can only provision one global service manager account per management group. So whatever amount of tests you have the capability of uploading, it's only for that one account. You can't provision multiple GSM accounts and add them into a single management group. And then lastly, we had traditionally restricted console access just for reliability and security concerns. And so, trying to span out or access to the console was something that just wasn't going to work in this single instance. So moving forward, what we've decided to do is provision new, smaller operations manager management groups for every business unit. And we're spinning these up to handle as many as 3,000 agents. In the case of Microsoft.com, in the case of Windows Update, that's the size that we're having to spin up. For some of our other customers, it will be smaller instances. So what does this enable? It enables us to actually provide that console out to a larger user base. It allows us to have multiple GSM accounts, one for each of these business units, so we're not running up against a test limit immediately because all of these folks are trying to add tests. Next, it allows them to have their app owners or engineering teams create the APM configurations. We won't centrally manage that for them. They'll actually have access to the console to do that. And then, likewise, they'll have access to set up their own web tests. So this is something we're very excited about moving forward. We already have 5 dedicated instances rolled out to production, and we're in the process of actually building out the one for Microsoft.com right now. Everything you saw Jim demo was part of their pilot instance, which is all running on VMs. So we really didn't expand it beyond about 300 agents reporting in, and I think you've got maybe 12 to 15 applications reporting in. So it creates a challenge as far as managing and supporting those, yes. Our team is working on building out the processes and efficiencies to try and make sure we support it with the same staff, right? But each one of these teams will have their own data warehouse. They'll have their own OpsDB. It will be their own entity. However, we will continue to have a shared instance, a very large shared instance, which will be monitoring each one of these management groups. And all the agents will be dual-homed to both the dedicated instances and the shared for failover capability. Believe it or not, we're actually rolling it out, and it's per customer. It's not really increasing the amount that they pay all that greatly. We can go into more details later. I actually plan on doing a bunch of blog postings about this over the next couple months, so you'll have some information there. Any other questions about what we're doing there? Coincidentally, this is also something the product group is looking into, because if your customers are anything like we've been, their reins on the Operations Manager console are very tight. They don't want to give that out. But the only way you can dispose of these features is to get the consoles there. So this is something that we're working with the product group on. Lastly, so I hope that this has been informative. I hope that you've found the features that we've gone through to be useful for your customers. I'd love to hear some feedback if you've got some concerns or some scenarios that you think wouldn't necessarily fit in some of these. And you know, we would like to open it up to questions. We have very limited experience monitoring SharePoint applications using the SharePoint MP. I know that we've monitored some SharePoint applications using web availability monitors, but not necessarily using the
services or anything like that. So we have a couple of small footprints of SharePoint. We haven't really pushed any of the APM configs out there yet, just because we haven't really seen that many issues. They're pretty consistent in their performance and availability behavior. But it's something we're definitely looking at leveraging in the future. But yeah, right now, you're only going to get the web front end, and so there are some limitations to what you get out of it with APM. But I don't have a lot of experience with it yet.
So there is one thing that we haven't done a great job with in our centrally managed instance is experimenting with role-based access. And stepping our toe into handing the console out using that model. But it is something that we will look at in the dedicated instances and provisioning out the ability for unique app owners to go ahead and just create web tests for their app. So the other thing, hopefully what they'll end up doing is enabling some PowerShell to be able to quickly create and modify one or more. So, like I said, we've got 5 in production right now, and we've got 2 more on the way, and so we should be completely migrated over no later than... If not, well, thank you very much for attending. Breakout sessions, Chalk Talk, sorry. And then there's a few other breakout sessions from our monitoring and management team. And then we're posting our blogs up to the technet.com/b/wincat